Yes. Is it visible? Yes, guys. So now, yes, beta. Is it visible to you all? Ask others to join, please. Oh, wait. Mm-hmm. Okay, Praharsh, Saad, Rishi. What about others? Please ask others to join. I will wait for some time so that all will join. बाकियों को मैसेज कर दो यार. ओके, आशीष, हर्षिल, साथ फोन कर देना यार. ओके वरुण, ग्रेट. यश, okay, other will join in the meantime. So let us start. Oxidation of amines. So you know, amines, they form variety of oxidation products depending on the nature of the oxidizing agent and the amine. So let us say primary amines. First, oxidation of primary amines. So primary amines, you know, the oxidizing agent, you know, main is KMnO4. So when KMnO4 oxidize this ethylamine or even isopropylamine, so in both cases, what happened? First, dehydrogenation takes place. We get imine. Okay, we get imine as the products. ठीक है ना? Acetaldehyde है ना? And which on hydrolysis gives acetaldehyde along with ammonia, or this one isopropylamine on hydrolysis gives, you know, acetone along with ammonia. Acetaldehyde, acetone. Okay, this is isopropyl amine, right, and this is ethylamine. So see, ethylamine will give acetaldehyde, सर किच दिख नहीं रहा है, मेरे साइड से प्रॉब्लम है या मेरे, बेटा तेरे साइड से प्रॉब्लम होगी, ये तो बिल्कुल सही दिख रहा है, मुझे भी दिख रहा है, मैंने दूसरा मोबाइल भी रखा हुआ है ना अपने सामने, है ना. तो देखो, इथाइल अमीन फर्स्ट ऑन ऑक्सीडेशन गिव्स इमाइन. ओके, मीन्स सिंपल डिहाइड्रोजनेशन हो रही है, H from CH2 and H from NH2, and we get imine. And in isopropyl again H and again dehydrogenation, and then which all hydrolyzed. When it is hydrolyzed in acidic medium, we get acetaldehyde from ethylamine and acetone from isopropyl amine, right. So, this is the products of oxidation of primary amine. Now, let us study of for secondary amines. Now, in secondary amines, it is like this, like diethyl amine. So, diethyl amine, it can be oxidized with KMnO4 or with H2SO5, that is called Carrot's acid, or persulfuric acid. So, when it is oxidized with KMnO4, then there is a formation of product like this. So, say NH2, what is the name of this compound? This is hydrazine. So, this one is tetraethyl hydrazine. This is tetraethyl hydrazine, okay. And same diethylamine can be oxidized with Carrot's acid. Carrot's acid is H2SO5, okay. So, Carrot's acid, then it will give product like this. This is N-hydroxy diethyl amine, right. So, see the difference. When we have KMnO4, then we get derivative of hydrazine, that is tetraethyl hydrazine, okay. And when we have Carrot's acid, or it is also known as persulfuric acid or peroxosulfuric acid, okay, then because it has a peroxide linkage, okay. So, we get N-hydroxy diethyl amine. Now, tertiary amine. So, tertiary amine, when let us say triethylamine. So, triethylamine on oxidation with KMnO4, we get triethylamine oxide. Okay. So, triethylamine on oxidation with KMnO4, we get triethylamine oxide, right. So, primary amine, secondary amine, tertiary amine, they oxidize differently. See, primary amine give aldehyde and ketones, secondary amine will give hydrazine or N-hydroxy amine, or tertiary amine will give triethylamine oxide, okay. Now, D, that is aniline. So, aniline, aniline is quite sensitive to oxidation because it has a resonance structure, okay. This is a coordinate bond between nitrogen and oxygen beta. C2C, no need to write here, simple C. In this case, C2H5 thrice, and it has a lone pair, and oxygen need 2 electrons to complete its octet, and nitrogen has a lone pair, so it will form a coordinate bond between nitrogen and oxygen. Okay. So now let us take the case of aniline. So aniline, it gives different products depending upon the oxidizing agent used. Like if we have KMnO4, sorry, KMnO4 is not used here. Let us take, we have H2SO5, that is called Carrho's acid. So Carrho's acid will give nitrosobenzene and nitrobenzene. Okay. Nitrosobenzene and nitrobenzene as the product. Same aniline, if react in the presence of this is peroxo trifluorosulfuric acid. Okay. See, CH3 C double bond O OOH. This is like this. Okay. Peroxy trifluoroacetic acid. Okay. So it will give nitrobenzene as the product. Okay. And last one is in our syllabus. Means that is in NCERT, that if we have aniline on treatment with chromic acid, then we get this product, parabenzoquinone. So see, the different products are formed. If we use Carrho's acid, we get mixture of nitrosobenzene and nitrobenzene. If we use peroxo trisulfuric acid, we get nitrobenzene. If we use chromic acid, we will get parabenzoquinone. Right. So these are the oxidation products of different, means anilines with different oxidizing agents. Now next one, that is the reaction with nitrous acid. Yes, tell me, what is nitrous acid? What is nitrous acid? So nitrous acid is HNO2, or we can write it as HON double bond O. Okay. So all the three members of the amines, aliphatic or aromatic, they react with nitrous acid under different conditions to form variety of products. And nitrous acid is highly unstable and it is prepared in C2. You know what is C2? C2 means which is prepared in reaction mixture by the action of HCl, very good Charitre, by the action of dilute hydrochloric acid on sodium nitrite. So HCl, when react with sodium nitrite, we get HNO2 and NaCl. So this is the nitrous acid which is prepared in C2. Okay. So let us see what happened with primary aliphatic amines. Okay. So primary aliphatic amines. So primary aliphatic amines, when they react, let us take ethylamine again. So on treatment with nitrous acid, which is prepared from, yes, which is prepared from dilute HCl and NaNO2 at 273 to 278 Kelvin, okay, ice cold solution. Then we get ethyl alcohol along with the effervescence of nitrogen gas and H2. Okay, these are the product formed, and this is a test for primary aliphatic amines, because no other amine will evolve nitrogen gas with nitrous acid. Only primary aliphatic amine will give nitrogen gas, effervescence of N2 gas, okay, with nitrous acid. It can be written as C2H5 N H2 HO NO. We can remember like this: C2H5OH N2 and H2O. Okay, done. So with primary aliphatic amines, we get alcohol along with the effervescence of nitrogen gas. Okay, now next is with primary aromatic amines. That is well known. So primary aromatic amines, wait. Okay, so with primary aromatic amines, what would we get? You know, primary aromatic amine, aniline is the best example. Okay, so aniline, when react with nitrous acid, first of all, you know, in nitrous acid, when that is formed, we have HCl along with NaNO2. Okay, so first of all, aniline react with HCl, which is present there. Okay, so we get aniline hydrochloride at the same temperature 273 to 278 Kelvin. Okay, ice cold solution. Then the nitrous acid will react under same conditions of 273 to 278 Kelvin. So we get benzene diazonium chloride. This is also called diazotization reaction. This is benzene diazonium chloride, and this reaction is called diazotization reaction. Okay. Now, you know, the temperature should be between 273 to 278 Kelvin. So what happens if temperature is more than 278 Kelvin? Can you tell me? If temperature is more than 278 Kelvin, then what would happen? So see, if temperature is above 278 Kelvin, then immediately it gets hydrolyzed and we get phenol. as the product formed along with nitrogen gas and HCl. That's why while preparing benzene diazoxide chloride, keep in mind solution should be ice cold. Only then we get phenol. Otherwise, it is converted into, we get benzene diazoxide chloride. If temperature is above 278, we get phenol as the product. Okay. And aliphatic primary amines, when they react, they also react in the similar manner. See, when we have this ethylamine, okay, so ethylamine with nitrous acid in acidic medium in ice cold solution. So first of all, same product is formed, means diazonium salt is formed, but diazonium salt of this I can say aliphatic amine is highly unstable. It is not stable even in ice cold solution. So immediately it gets converted into ethanol, which is the major product formed, along with even ethyl chloride is formed to small extent, or ethene is formed, or nitrogen gas even. Okay. So keep in mind, ethyl alcohol is formed, but along with ethyl alcohol we can get a small amount of ethylene and ethyl chloride. Shit. Okay. But a cold solution is used because that if we don't have cold solution, then say N2 is highly stable product, so it can break easily and we get N2 gas as the main product. Okay, that's why we use ice cold solution. Okay, and in case of aromatic amine, that is somewhat stable, but in aliphatic amines even that solution is highly unstable because nitrogen is very stable gas. Okay, so that is separated from the salt. Okay. Okay, so next is, got it, Muskan? Now secondary amines, both aliphatic as well as aromatic can react with nitrous acid and we get nitrosoamines. And this nitrosoamine formed in secondary amine separate as a yellow oily liquid. This is yellow oily liquid because see, this H and OH, that is removed and we get CH3 CH2 twice N and double bond O along with water. So it can be remembered as, see, CH3 CH2 twice N H and then N double bond O OH. So it is like this. This is one of the product and this is the second product. Okay. So N nitroso diethylamine is formed. N nitroso diethylamine, and this is yellow oily liquid. See, other products formed like ethylamine, diethylamine, nitrous acid, they are water soluble. all are water soluble, but when this product is formed, this is separated as yellow oily liquid. Okay. Same if we have secondary aromatic amine like this. Okay. Let us say this is the product, this is the reactant, N-methyl aniline. Okay. So, N-methyl aniline when react with nitroso, so we get obviously HOH, that is removed, and we get this product along with water, that is N nitroso N methyl aniline. Okay, that is the yellow oily liquid. Okay, beta end of the March maybe. Okay. So, next is tertiary amines. So, in tertiary amine, tertiary aliphatic amines, and then we come to tertiary aromatic amines. So, in tertiary aliphatic amines, like let us discuss first tertiary aliphatic amines. Like triethylamine. Okay. So, triethylamine when react with nitrous acid, again in the cold, you know. So, first of all, you know, there is no hydrogen at all. So, simply, you know, it has lone pair. So, because of the presence of lone pair, this HNO2 will give H plus to this lone pair. So, we get this as a cation and NO2 negative as an anion. So, this salt is formed. Okay. So, first of all we get this salt. Say in primary amine there is 2 hydrogens. Okay. So, one of the oxygen go with that. Okay. And in case of secondary we have 1 hydrogen. So, OH will go with this. Okay. And now we have no hydrogen on the amine. So, only H plus ion, because this act as base and HNO2 act as acid, means acid base reaction takes place, and which on warming will get C2H5 twice and N double bond O along with C2H5OH, right. This is the product formed. So, this is diethyl nitroso amine. So, this is the product formed, or we can say N nitroso diethylamine. Now, next one, that is the tertiary aromatic amine. Tertiary aromatic amine. So, tertiary aromatic amine, you know, tertiary aromatic amine is like this: N dimethyl aniline. NN dimethyl aniline. So again there is a lone pair, but at the same time, you know, lone pair can activate its ortho and para positions. Ortho positions are sterically hindered because of these bulky groups. It is like this. Because of the bulkiness of the groups, these positions are not appropriate to attack for the electrophile, but para position is sterically less hindered. That's why, you know, HONO, you know, HCl is there in the mixture. So in the presence of acid, it will give H like this. So water is removed, and along with this we get nitrosonium ion, and this nitrosonium ion, you know, electrophilic substitution reaction takes place. So that will attack at para position along with the formation of water. Thank you, Muskan, for your appreciation. So in this way, para position is means hydrogen atom at the para position is replaced by nitroso group. So this is the product formed. So what is its name? You know, para nitroso, or we can say 4 nitroso NN dimethyl, sorry, NN dimethyl aniline. Okay. So these are the products of with nitrous acid. Then first we carry out with those oxidizing agents. Now main reactions of aniline, that is electrophilic substitution reactions. Electrophilic substitution reactions of aromatic amines. So you know, this is aniline. So aniline, you know, because of the presence of lone pair, in conjugation with ring, so first product is this, negative charge is at ortho position, then negative charge is at para position, it is like this. Okay, means lone pair, negative charge is at ortho and para position. Okay, and that's why, you know, electron density on the ring increases, particularly at ortho and para position. So NH2 group is activating because it increases electron density on the ring, and electron density is increased particularly at ortho and para position. Therefore it is ortho para, directing towards, yes, towards electrophilic substitution reactions. Okay. So let us start with halogenation. So in halogenation, you know, this is aniline, and you know, it is more electron releasing than OH. Am I right? Because oxygen is more electronegative and nitrogen is less electronegative. So on bromination in aqueous solution, or we can say in bromine water, all the three positions, ortho as well as para positions, they are substituted with bromine. Okay, along with HBr, that is we get 2,4,6 tribromo aniline. Okay, which is of light yellow precipitates. Okay, so see, all the three positions are occupied, ortho as well as para positions, because the polar solvent like water that increase the electrophilicity of bromine. Got it? What I said? Polar solvents like water increases the electrophilicity of bromine. Okay, right? But if we have non-polar solvent like CS2, then there is ortho and para products are formed only. See, aniline with bromine in the presence of non-polar solvents like CS2 or CCl4, then in the presence of non-polar solvents, electrophilicity of bromine is relatively less. As a result, halogenation occurs only at ortho and para, means only mono substituted product is formed. Para is the major one because of less steric hindrance. Okay. Now, if we have aqueous solution only, but we would like to form mono substituted product only. Okay. So in that case, first of all, we have to protect this NH2. Protection means we have to decrease the activating influence of NH2. So what we do, first of all, we treat it with acetic anhydride. Okay, when we treat it with acetic anhydride, there is a removal of acetic acid in the presence of pyridine, so that the acid formed is neutralized and we get the product like this. This is also called acetylation of aniline. Now, what happened in acetylation? See, this lone pair on nitrogen which activate the ring, now it is involved in cross conjugation. See, it can go like this or on the other side. That means now activating influence of NH2 is somewhat decreased. Okay. And now if we do the bromination, even in aqueous solution, we will get either ortho or para product. Obviously, para product is the major one because of steric hindrance at ortho position. Okay, and now if we hydrolyze it in acidic medium, there is a removal of acetic acid and we get orthobromoaniline or parabromoaniline. Yes, yes, very good. Okay, 4-bromoaniline and 2-bromoaniline. These are the products formed. Right? Any doubt? So, there is need to protect this group. If we brominate in aqueous medium and we would like to form only mono substituted product, but if medium is non-polar, there is no need to protect it. Done? Now, second one is nitration. Nitration, you know, for nitration we use nitrating mixture, that is concentrated nitric acid along with concentrated sulfuric acid. Done? So, keep in mind when aniline undergo nitration, obviously, you know, we have just done that when it is nitrated, NH2 group is orthopara directing. So, obviously, we have in mind that ortho and para product is formed and only these are the two products formed, okay, and para should be major. But surprisingly, what happened along with this, meta product is also formed. See, ortho, para and meta is not in small amount, it is 47% and para is obviously major one, that is 51% and 2% is ortho. Why meta product is formed? Tell me. Can you guess? How do we get meta product? And you know NH2 group is orthopara directing. NH2 group is orthopara directing. So meta product, how do we get this? Ashish, my question is why we get meta? No, you are wrong. Say ortho para product is maximum, then meta. How do you say that NH2 is meta directing? Very good, because you know HNO3 as well as H2 both are acids. So solution is acidic actually, and you know NH2 group aniline is acting as a base. So in strongly acidic medium, H plus obtained from acids, so we get anilinium ion, and you know anilinium ion is electron withdrawing group and it is meta directing. Anilinium cation is formed, okay, which on nitration water is removed and we get meta product because it is meta directing. Yes, you are right, beta. And then H plus ion is removed and we get meta nitroaniline. Okay. Now to get the single product, what we do? Again, we should check the activity of the aniline. So to get the single product, we remove the chances of para product. First of all, this NH2 aniline is acetylated with acetic anhydride. Okay. So when it is so what is the name of this product? Tell me. We have done it earlier. This is called, yes, acetanilide. Okay. And when now it is nitrated, obviously para is the major product. So now we get ortho nitro and para nitro, and para is the major product, which on hydrolysis yes, product formed is orthonitroaniline and para-nitroaniline. Good. Orthonitroacetanilide, para-nitroacetanilide. Now, after nitration, sulfonation. Now, in sulfonation, we start with aniline. Aniline is a base and H2SO4, it is strong acid. So, again acid base reaction takes place and we get aniline hydrogen sulfate. Okay, aniline hydrogen sulfate. Okay, after getting this aniline hydrogen sulfate, when it is heated at 453 to 473 Kelvin, we get the rearranged product, in which this NH2 and SO3H, that is called sulfonilic acid. So, in sulfonilic acid, you can say there is acidic group and basic group. So, it can exist as dipolar ion, or we can say Zwitter ion. Okay, and this dipolar ion or Zwitter ion, due to the formation of this, it has very high melting point. Okay, it exists as an crystalline solid. Okay, and it is dissolved in water. In hot water, it is soluble. but it is insoluble in organic solvent because of its ionic nature. As it is ionic in nature, so it is soluble in water, but it is insoluble in organic solvent. Okay. Yes, beta. Only last thing, last words of the day, which are very important, that aniline does not respond to alkylation and acylation. Just like carboxylic acid, aniline also does not respond to both alkylation as well as acylation in the presence of anhydrous AlCl3. According to Friedel-Crafts reaction, you know, AlCl3 is used as a Lewis acid which can accept electron pair of on the nitrogen atom. Okay. So, AlCl3 that form complex with aniline. Okay. So, amino group that will get positive charge and AlCl3 will get negative charge. Okay. So, that deactivate the benzene ring, and that is why electrophilic substitution reactions involving alkylation and acylation are not feasible. Very, very important. Why aniline does not respond to Friedel-Crafts alkylation reactions? So, reason is because AlCl3 which act as a Lewis acid, will react with aniline being Lewis base and form the salt, and then nitrogen get positive charge and therefore it deactivates the benzene ring. Okay. And because of that, electrophilic substitution reactions involving alkylation or acylation are not feasible. Done. So, thank you so much. Bye bye to all. God bless you. Okay, good night.